Good morning. We are going to look at our solution to our assignment. We're given you some three equations to find the stationary points. We're asked to find the stationary points, and we determine their nature. Stationary points are the same thing as turning points. As we said, the major characteristics at the turning point. The major characteristics of a stationary point or a turning point is that for any stationary point, the gradient function dy dx is equal to 0. And if you're asked to determine the nature, we know a stationary point can either be number 1, maximum, number 2, minimum, or the last one, inflection. So if we're asked to determine the nature, they want you to classify that particular stationary point into any of the following categories: maximum, minimum, and inflection. Good. Let's go on. Now, let's determine the gradient function dy dx from our given equation. dy dx from this equation will be 12x squared plus 6x minus 6. Since at the gradient function dy dx is equal to 0, 12x squared plus 6x minus 6 will be equal to 0. Then we can simplify this expression further before factorizing, or if you like, now start factorizing, doesn't matter. 6 can cancel 2, so we can use the 2x squared plus x minus 1 is equal to 0. Then we factorize this expression. I have 2x squared plus 2x minus x minus 1 is equal to 0. Factorize the first two. The common thing is 2x, x plus 1. Here we'll factorize 1 out. X plus 1 is equal to 0. So we have 2x, it's minus 2x minus 1 bracket, x plus 1 is equal to 0. This implies 2x minus 1 is equal to 0. S is equal to half, or s plus 1 is equal to 0, s is equal to negative 1. So the x coordinate at the turning point is negative 1 and half. Then we need to go and determine the y coordinate at the turning points. Or better still, we can just straight away determine the nature, because since we are looking for points, it means our answer should be of the form sy. We have gotten the 2 points with only the x values. So at this stage, I know I have one of the point to be negative 1, y, I don't know the y value, and then 1 is half, equally, I don't know the y value. Let me just write y2. So we are going to determine the y1 and y2 to represent the stationary points on this particular curve. We can at this stage determine the nature if you want, or we can calculate for our values and later on determine the nature. But let's determine the nature. To determine the nature, we need to find the second derivative, the square y over the x squared. So we have to differentiate this function again. And differentiating that function again, we are going to get 24x plus 6. So at s is equal to negative 1, our second derivative, the square y over the x squared, will be equal to 24 multiplying negative 1 plus 6 and that will give us negative 18. And since this is negative, it means the point at s is equal to negative 1 is maximum. Remember, maximum because our d square y over dx squared is less than 0, is negative. Then let's test the point at, let's test the point at s is equal to half. This point. Let's test that one too. At s is equal to half. When x is equal to half, our d square y over the x squared will be equal to 24 into half plus 6, and that gives us positive 18. So it means this is what? Minimum because we got a positive answer. Good. Then let's go now and solve for the corresponding y values using the original equation. Using the original equation. The original equation is y is equal to 4x cubed plus 3x squared minus 6x minus 1. When x is equal to negative 1, we just slot in our y will equal to 4 negative 1 cubed plus 3 negative 1 squared minus 6 times negative 1 minus 1. And that will translate into 4. That will translate into 4. So it implies our, remember, let's see, at negative 1, what did we get? At negative 1 is maximum. Okay, so it means at s is equal to negative 1 is maximum. So it means the turning point negative 1, 4 is a maximum point. Maximum point. If we write it without indicating that it's a maximum point, let's now find the corresponding value of y when s is half. So when s is equal to half, our y will be equal to 4 into half cube. 4 into half cube plus 3 into half square minus 6 multiplying half minus 1. And if solve further, get negative 11 over 4. So our point now becomes half, comma, negative 11 over 4. Minimum point. Minimum point. So that's the first question. This is our minimum point, and this is our maximum point. And this is our maximum point. Good. So we're able to determine the turning point, or otherwise known as the stationary point. And we have determined their nature, whether they are maximum, minimum, or point of inflection. In this case, it is only maximum and minimum. There was no point that is point of inflection. Let's go to the B. Okay, let's look at the B. The B, the equation is y is equal to 4x, x to the power 4 plus x cubed minus 6. Good. The same preamble, we are looking for the turning points and the nature. So we have to differentiate the functions. dy dx is equal to 4x squared plus 4x cubed plus 3x squared minus 0. So that one drops. At that point, at the turning point, 4x cubed plus 3x squared will be equal to 0. We factorize. The common thing is x squared. X squared out, we have 4x plus 3 is equal to 0. Solving further, x squared is equal to 0 implies x is equal to 0. And then 4x plus 3 is equal to 0 implies x is equal to negative 3 over 4. So at the turning point, we have our two coordinates, the coordinate for x. So now, ideally, we can say the turning points are 0, y1, then minus 3, 4 over 4, y2, where y1 and y2 are the corresponding values of y we need to determine. We can at this stage, as I'm saying, always say, determine the nature, or you can find the y coordinate the later on, determine the nature, whatever you want. But I wish that at this stage, just determine the nature, then later on you find the y coordinate. So I'm determining the nature. To determine the nature, I will need a second derivative, the square y over the x squared. In that instance, I have to go and differentiate this function again. And that will give me 12x squared plus 6x. At x is equal to 0, mind the square y over the x squared will be equal to 12 0 squared plus 6 times 0. And this will translate into 0. This means the point at x is equal to 0. The point at s is equal to 0 is a point of inflection. Point of inflection. Remember, a point of inflection, x is equal to 0. When it's less than 0, it's maximum. Greater than 0, minimum. Exactly 0, point of inflection. Let's test the other point. So we have finished testing this one. Know that this is point of inflection, but we'll come and calculate the corresponding values of y using the equation later on. We are now going to test this point and see which point is that. Good. We are still using the second derivative, 12x squared minus plus 6x. So let me write the equation down here. 12x squared plus 6x. We are going to test at x is equal to minus 3 over 4. Our the square y over the x squared. Square y over the x squared will be equal to 12 minus 3 over 4 squared plus 6 minus 3 over 4. Solving further, we'll realize that this will give us negative 21 over 4. Sorry, over 2. So at the point where s is equal to negative 3 over 4, the curve is what? Maximum. Or otherwise, we have a minimum point. At s is equal to negative 1, there is a minimum point. At s got negative 3 over 4, there's a minimum point. Then let's now calculate the corresponding values of y using the original equation. The original equation is y is equal to x power 4 plus 6 let me see, x cube, x cube, x cube, then minus 6. When x is equal to 0, y is equal to 0 is the power 4 plus 0 cube minus 6. Y is equal to 0 implies we have 0 comma 0. But that is point of inflection, remember? Then when s is equal to minus 3 over 4, when s is equal to minus 3 over 4, our y is equal to minus 3 over 4 cube, sorry, raised to the power 4 plus minus 3 over 4 cube minus 6. Punch in your calculator, y is equal to negative 15,563 over 256, or otherwise decimal equivalent minus 6.11. So we have minus 3 over 4 comma negative 6.11 as maximum point. Okay, let's look at the C. Let's look at the C. Y is equal to x plus 4 over x. To be able to differentiate this function effectively or very simple, we need to rewrite this function as y is equal to x plus 4 x to the power negative 1. That's by the laws of indices. The 4 over x can be seen as 4 multiplying 1 over x. And by the laws of indices, if I have a raised to the power negative 1, the same thing as 1 over a. So if I also have 1 over a, I can write it as what? A raised to the power negative 1. Similarly, if I have 1 over x, I can express it as what? X to the power negative 1. So that is the scale we have employed, is indices, the rules of indices. Now that's like this, we now go on to do our differentiation. We differentiate the function dy dx. We are now employing the same principle. The power will multiply the coefficient. So here is 1. Then we reduce the power by 1, the x will drop. The power will multiply the coefficient, will get negative 4. So 4. Then reduce the power by 1, become minus 2. Okay. So we have 1 minus 4x raised to the power negative 2 is equal to 0. Because it's a turning point. The same preamble as the A and B. I can rewrite this as 4 over x squared. The same illustration as I did with the indices. And I multiply through by the LCM, x squared. Become x squared minus 4 is equal to 0. Now, I factorize this expression. Remember, this difference of 2 squared, it can be understood as x squared minus 2 squared is equal to 0. Difference of 2 squares. If it's difference of 2 squares, then it can be factorized as s plus 2 in one bracket, s minus 2 in one other bracket. This is equal to 0. So solving for that, half s is equal to negative 2 or 2. It means my points are negative 2, positive 2, and a y coordinate I'm yet to find, and -2 another y coordinate I'm yet to find. But I want to investigate the nature of these 2 points first. I have to use what the second derivative, y square y over x squared. So I'll differentiate this function again, and that will give you, when you differentiate the one, it will drop. But when I differentiate the second term, this one, to give me +8. Remember, the -2 multiplied the -4. Then I'll reduce the power by 1. -2 minus 1 give me -3. Then at s is equal to 2, I'll have 2 raised to the power -3. That'll give me +1. And if it's +1, then it's what? Minimum. Then at s is equal to -2, I'll have minus square y over the x squared will be equal to 8 minus 2 raised to the power -3. And that'll give me -1. And that is maximum. Then I come here to find the corresponding y coordinates. When x is equal to +2, y is equal to 2 plus 4 over 2, and that is 4. So I have, that's 4. So I have 2, 4. 2, 4 as my minimum point. Minimum point. My minimum point. Okay, then when x is equal to -2 and y is equal to -2 plus 4 over -2, and that becomes -4. So I have -2, -4 as my maximum point. Maximum point. Good. Maximum point. Let's look at the last question, question 3. Let's look at the last question. That was rather question 2 rather. The first one was question 1 ABC. So this is question 2. So the curve y is equal to ax squared plus, y is equal to x squared plus ax plus b, this one, has a turning point. When you hear the word turning point, you divide the x is at 1, 3. Find A and B. The turning point is at this place. What this question is just asking us to find the values of A and B given the turning point. The previous questions we just solved, the equation is given and you were supposed to obtain the turning point. But now they have given you the turning point and a certain element within the equation. There is nothing, it's the same procedure. We know that at the turning point, the y dx is equal to 0. So this equation, my dy dx is 2x plus dy dx is equal to 2x plus a. So my 2x plus a is equal to 0. Solving further, my 2x is equal to minus a. Initially, we would have solved for the x value, but now the x value has been given. Initially, we would have used this to solve for the x value, but the x value has been given. So just plug it inside. Since s is equal to 1 at the turning point, say 2 times 1 is equal to what? minus a implies a is equal to negative 2. This one, they didn't ask anything about nature, so you don't go even solving for the second derivative. They didn't ask of the nature of the curve. We are not interested in the nature per the requirement of the question. But initially, when you have your x value, what do? You slot it into the original equation to get a y value. But now we have all the x and y. So we slot everything. The original equation is x, y is equal to x squared plus ax plus b. So we slot everything. Y is 3. Then x will be slotted. So 1 square plus a is 2. So we put it there. Times 1 plus b. So 3 is equal to 1 plus 2 plus b. This becomes, so this is negative 2. Let me do that correction. Negative 2. I'm coming. This is negative 2. So minus. Okay. So we have 3 is equal to minus 1 plus b. Solving for that, b is equal to what? 4. So a is equal to negative 2, b is equal to what? Positive 4. So these are our answers. Okay. Thank you very much for watching. Have a nice day.